Okay, so I'm just going to walk through the study guide for the topics we're going to be covering on the exam, first exam. Um, First, I guess the concept of hyper competition. If you remember, we had talked about this, the idea that there's always been competition in business, and organizations have really striven to identify, maintain, and defend a competitive advantage in in competing with other organizations. One of the things we've seen, though, within the past 20 years or so, is that um, competition has really stepped up. The idea of establishing and maintaining, sustaining competitive advantages um, has really become much more difficult. And a large portion of that, reason for that, is the fact that uh, information technology has provided a means by which you can other types of other competitors, other organizations um, can improve their business processes, can improve their or compete with you in different ways. So the idea of a um, defensible competitive advantage really is not what it used to be, and organizations are compelled to continue to are challenged on an ongoing basis to continue to move and control and try to deal with this. Um, okay, management information systems. If you recall, we talked about MIS as a business entity. It's not technology; it's business, and with the different components of it, a line between people, technology, and processes. Kind of that the balance between um, those three elements. So it's not just the technology; it's a combination of both the technology, process, and people. And in large portion, the people um, are really the more challenging a lot of times present more of a challenge in working through people issues as it would be just the technology. Even though technology is supposedly very complex, you can manage technology. People need a lot more work. Um, the five forces model, Porter. So remember, Porter had three. We talked about three of Porter's theories. One was the generic competition. The second one was the value chain. And then the third is this idea of the five forces. The idea of the five forces is, organizations are not simply competing against each other, but there are other factors that come into play which organizations have to deal with. So the five forces, so basically your kind of core competition with other companies is your first force. But in addition, you also have a force represented by the organization's suppliers, as well as the organization's customers. All right, so each one of those can um, have a weight on how decisions are made or issues that have to be resolved, either on the front end or the back end. All right, and the other two, but in addition to those, you also have situations where um, you have new products, new competitors coming into the market, you know, who can also compete. And then in addition, there's also this idea of substitute products, as stuff you are selling into your space. And if another product comes along, could be cheaper, could provide more value, would be another issue to have to deal with. All right, so the importance of the five forces is, especially from the IT perspective, is that a lot of times organizations will use information technology to help mitigate the forces on the front on the supply chain side, on the back end, the supplier force, or on the customer force, CRM systems. All right, so you use that to be able to get better control or get better, I guess, insight into what's happening in those two different domains. Um, Speaking of the value chain model, basically the basic elements of are you reorganize your um, company in such a fashion so everything that is aligned with your core um, production processes uh, flow on an end-to-end basis, and that's what we call the value chain. Because the idea is, as you're moving through the chain, you're increasing value as you move from the first area to the second area to the third. ultimately increasing in value, ultimately being directed to the customer. And then the other parts of the organization are really considered supporting. Not that they're less important, but it's really alignment of you know kind of the core processes that that really drive the value creation within the company. Balanced against the other organizations which are designed to hold basically provide support around that. So managerial decisions. So we talked about a couple different types of decision making, around this idea of information systems, and ultimately management is all about making decisions. Um, we, as we were at the kind of the lower levels, we talked about kind of at the business process level or the transactional level, there's decisions that are made there, but those are pretty straightforward. Pretty much there's a um, not a not so much as not a lot of thought to them, but they're fairly straightforward kinds of questions. So which basically you can get that type of, you look for things like that, assistance to that, and really in things like reports or just kind of decisions from day to day. Managerial is actually the next level up, so it's not a structured um, kind of decision. It's kind of a semi-structured decision. So there's actually a lot of there's variability. There's things that have to be analyzed. There's different factors that kind of come into play. So it's not a strategic. It sits between kind of your task level decisions and your strategic decisions. Around making those types of things. So the idea would be, now this is really the area where we see decision support systems, the DSS systems. Those are the areas where we're looking at things like managerial support. Key performance indicators, critical factors of success is really how we're monitoring activities. How do we monitor activities in a business? Key performance indicators are really those um metrics that for example, sales or uh, returns, or basically anything that you can use as a guide to give an evaluation, provide an evaluation of what's happening, from the business side. Critical factors for success are, CSF is really, another set of metrics which are really aligned around the idea of, okay, what are the things we have to watch? What are the critical factors? They're aligned to the KPIs. So, you look at the KPIs as a means of evaluating where you're at against the CSF. Enterprise applications. Remember, we talked about the kind of the rise of these enterprise scale applications over the past 20 years. And they have different functions. So, at the heart of it, we have something we call the ERP system, Enterprise Resource Planning System, ERP, which is an integrated um, software platform which provides the capability of providing all the different types of business processes, or supporting all the business processes that an organization would involve. So it would include everything in your sales, everything in your purchasing, everything in your maintenance, everything in your accounting. So all of these functions are provided in one platform and they're all integrated together. Supply chain management, SCM, is a platform that assists with the relationship between an organization and its suppliers. So, in communication with suppliers, uh, tracking what requirements are going to be, the idea of knowing what you want to buy, when you want to buy it, how much do you want to buy. All right, so that's on the supply chain side. Supply chain and ERP are kind of, well, a lot of times will work together, be integrating, passing information between those two systems. Similarly, on the front end, the CRM system, CRM, customer relationship management, really is tasked with identifying and tracking information and attributes related to customers. So, what are the customers buying? Um, what are the types of things? Trying to identify things like, what are customers interested in? What are their buying patterns? What are their, who are good customers versus not good customers? What are the characteristics of each? So that's And similarly, that will also talk to the ER. It can also talk to the ERP system. So as we said, these three kind of represent the core of the five forces model, software that gets implemented as a means of trying to control the five forces model. All right. DSS, decision support systems. A set of applications, reporting applications, analytics applications that support semi-structured decision making, used by managers. So it's not reports, but it's actually being able to combine different data from different sources and coming up with answers. EIS is the Executive Information System. So this is really, systems that are really focused on kind of tracking, analyzing, calculating KPIs and CPFs or CSFs, and then being able to present this information in a dashboard format. So it's a pretty, it's really, it's designed really to give you, at a glance, be able to consolidate large amounts of information. So a lot of times it'll take a lot of that stuff from the DSS system and transform it and provide it a representation of it, a visualization of it, which is a key factor in these EIS systems. OLTP and OLAP. Okay, so OLTP stands for Online Transaction Processing. It's the means by which ERP, SCM, and CRM applications run. So these are, basically you execute one, as we say, transaction at a time, which can be considered a step in a process or a task. If you have 15 tasks to complete a process, you could have 15 transactions, or maybe even more, depending, to complete a particular step in a process. All right. So online transaction processing. OLAP, which stands for Online Analytic Processing, is really more aligned with the DSS, Decision Support Systems, and EIS systems. All right. So those are really focused on providing analytics, reporting, being able to aggregate large amounts of information. A lot of the information, OLTP systems can do a lot, are designed specifically to run transactions. They're not good at reporting. They're not designed to be reporting platforms. OLAP systems are specifically designed around analytics, taking large amounts of data, being able to, reduce it, model it, perform statistics on it. So that's really what an OLAP is all about, very specific. So two different styles of computing. BPR, business process reengineering. If you recall, this is kind of Michael Hammer was the advocate around this, and the idea was, kind of similar to Porter, the need to reorganize a company and think around alignment with business processes. But Hammer, I think, was a little bit more direct, or a little bit more aggressive in terming it. This is not something that can be done on an incremental basis. This is something that needs to be done across the board, and it has to be done. Basically, you can't just tweak a couple things. Basically, you got to break it down and then build it back up. Right. And why is it challenging? Because it involves change. It involves changing an organization while it's still running, which is a lot of cases, organizations found that it took a lot more effort. They didn't know what they didn't know, in particular around in trying to understand and reform themselves around this idea of a process model was very, very difficult in a lot of cases. E-business solutions. We talked a bit about e-business solutions. Concepts around e-business solutions is the idea of leveraging technology to kind of using technology to reach out to customers, to change the way organizations operate, to streamline processes, to establish communication, and simplify interactions. So there's a lot of different reasons why businesses have focused on e-business. One of the key things is, at the outset, it was try to get a competitive advantage. Now it's basically to maintain a sustained place in the market. So much of the work is being, so much of commerce is being done, transacted through the internet. So it's to try to maintain and establish, um, a position, vis-a-vis other competitors, with relation to customers, and then with the connections they do have customers, be able to maximize, um, that interconnection, that interaction. Because really, what a lot of times what e-business is doing, one of the big advantages of it is it changes your relationship to the customer. So whereas, in traditional brick and mortar, organization could be separated by two or three or four layers from the customer. With e-business, they're a lot of times they're dealing directly. You're getting insights into what the customer is doing, how they do it, the frequency of what they do, which helps a lot in really is key factors in making decisions and trying to, fine tune your business operations. Um, History of the internet and difference between internet and World Wide Web. Remember, the World Wide Web, even though those two, a lot of times those two terms get used interchangeably, they're not. So the World Wide Web is only 30 years old. It was invented in '89, became released for commercial use. I think it was '91, all right, '92. But the internet itself, the plumbing, the interconnections, all the stuff that goes into the internet has been around, was originally developed back in the '70s. All right, so what we saw was the plumbing, the back end stuff was developed in the '70s and the '80s. The web was built on top of that, basically used that as the platform. Um, and then we go from there. Um, the differences between B2B, B2C, C2C, some of the examples. We talked about this around, um, business to business. Actually, one of the things that's interesting about this is that it's B2B and B2C, business to business and business to customer, has always been done. I mean, that's basically how businesses execute. The difference here is actually it's now doing this electronically, business to business with basically using information technologies to facilitate it, or business to customer using information technology to facilitate it. The Google business model and how Google makes money. Google's basically an advertising company. They're big innovation. Well, they're innovative in a couple different ways. So, at one level, from a technological level, they've done. They are the most advanced organization in terms of processing data, in terms of, mining the internet, searching the internet, basically crawling. That's just the term they use: crawl the internet, and identify locations of everything that's out on the internet, and then bring it back into their search engine, which lets people access stuff on the internet. So they're good on that. Now, but the real secret for Google is they found a way to monetize that, and the way they monetize that is through advertising. So what will happen is when you do a Google search, part of its process is it'll search, it'll bring back, but what it will also do, depending upon the search terms you use, it will automatically generate advertisements which get embedded in the results. And they're very inobtrusive. If you look at if you get something if you do a Google search and you come back and you'll see like maybe the first two or three or four items that are returned are actually advertisements. So if you click, what they call click through, if you click through to the site, then the customer, then basically the organization that put the ad up there will pay, but there's no charge for just bringing it up and presenting it on the screen. I mean, and it's a pretty big revenue machine. It's basically they're making 80 billion a year, some or 70 billion a year, or some pretty significant number driven by their from their advertising. So we talked about different revenue streams, come similar to what we had, advertising. There's for fee stuff. There's delivery of services. A number of different ways you can monetize this. The biggest one is quite clearly is advertising, but there are a couple. There are a couple of other ones, like the B2C, or C2C. Actually, like you think of Uber. Uber is a C2C customer to customer, with the Uber being kind of an interaction, the party that provides the connections between two customers. Key metrics, managing a supply chain. It's a whole bunch of, it's a whole bunch. The supply chain is focused on moving stuff around. So the question is, what the things you want to look at. The key metrics would be, I guess the items sold, obviously, inventory turnaround, items returned, perfect orders, orders executed end to end with no problems. Um, those are just kind of a number of those that get focused on as you're looking at the supply chain. Because the supply chain is actually two parts. One is the back end, which is between the supplier and the company, and then there's the front end, which is between the organization and the customer. All right, so those, I mean, delivery on time. There's a whole series of different metrics that you can capture, through ERP systems, CRM systems, SCM systems. Metrics around CRM, I guess some of the metrics around CRM systems, specifically around customers, around how customers, who your customers are, what are they buying, what are the things that motivate them to buy. Those are all different things you'd want to be looking at. Definition of a business process. Business process is a series of tasks uh, structured to be executed in a particular sequence to give you a expected output. All right, so that's the definition of a business process. The challenges that organizations found is number one is a lot of cases people didn't know what the business processes were. They were not really thought of as people would measure the results. They would measure revenue and they would measure cost, but not how things were actually done. So one of the big innovations that we saw back in the mid '90s tied into business process reengineering and implementation of ERP systems is going back and becoming much more aware of business processes and building basically around the idea of a business process as a means of execution. Um, Talk about the costs and challenges of ERP systems. I mean, the thing to remember about ERP systems, very difficult to do because really it's also being done in concert with changing an organization, changing an organization structure. Um, there's a lot of things that go into it. ERP projects, as I found, is a lot of times you find yourself going back and discovering things that have been buried deep in the closet for say 20 or 30 years. It has to be rectified. They've never been touched. The complexities around Hershey's was around the timing of their logistics, cutting short these things are take a long time, 48 month you know or plus cycle, and cutting that short basically they were basically moving it uh, into production without before it was ready. And what people discovered with these things are is that when you when you're building an ERP system and you're focusing on processes, there's a lot of interdependencies that never were apparent before that all of a sudden come to the fore. So there's a whole bunch of things that kind of you need to be concerned about with that. Okay, ERP, SCM, and CRM. We kind of talked about this, the relations to Porter's value chain. Think of ERP, SCM, and CRM as the core three forces in Porter's model, where ERP is basically used by the company as a means of competing, with other companies. SCM, is focused on trying to impact the force of suppliers, and CRM is focused on measuring or mitigating the impact or the power of customers. Mm. Talking about some different technologies that are coming in and how they're coming into supply chain is basically the idea of introducing technology into supply chain with the idea of simplifying it and accelerating it. All right, so RFID, radio frequency identifiers, be able to track materials as they move. 3D printing, which is actually new ways of creating materials. Drones, which have been talked about in terms of new means of delivery. Those are all kind of new innovations that could potentially have an impact on on supply chain operations. Not absolutely guaranteed. A lot of these things are never. A lot of things in introducing new technologies is never going to be quite as simple as you think it's going to be. All right, so how a web server works. Remember that we talked about. The web server is very simple. So actually, the internet at the lowest level is very simple. All right. Basically, what happens is the mechanics of a web server are um, web server is just a computer. It's running software that will listen, be connected on the internet, and can be addressed and is listening for requests. Request comes in generated from a browser. All right, so you basically send a question in or a request in. Um, the web server gets it, processes it, takes the results, and sends it back to the screen. All right, so that's really it. All right, so if you can imagine this happening a couple billion times an hour, that's the internet. So that's the mechanics. That's the basic mechanics of it. So it's a client server request respond type of setup. Talking about challenges, sustainable MIS. The idea that one of the things about information technology is that it has been seen as a disposable asset. So what happens is, the turnover, and some of this is driven by Moore's law, the next faster machines. An 18 to 24 month life cycle for an existing computer. Then you buy another one. Problem is the existing one's still around. All right, and what do you do with the existing ones? And you get, as we've scaled up and have moved from like one computer to a company to one computer on a desk to one computer, in a home to one computer in every pocket. The volumes and the numbers of these are things that have to be dealt with. The other issue to be really concerned about is, power consumption, energy. I mean, computers are, basically very, power hungry machines. So the idea of trying to, deal with the both um, the sustainable aspects of it, and trying to move to newer technologies, which will hopefully enable us to mitigate some of these sustainable things. This is an ongoing challenge for organizations and really from in general, basic society in general. So how do we deal with this stuff? So virtualization. So virtualization is an innovation that came into being about 2000, 2001 timeframe. And what the idea is that you have a one large physical machine, which you can then divide up and create, any number of smaller virtual machines that run within it. So you're kind of creating, using software to emulate hardware. All right, so you can take one machine, one big machine, and then create 1,000 smaller machines. So instead of having 1,000 machines consuming power, throwing out heat, um, basically you only have like one. Right? And this has been probably over the past 18 years. This has been the driver. So most organizations have moved some or all of their technology infrastructure to virtualization. The four components of MIS are hardware, software, network, and data. All right. So hardware, software, and data have been around from every computer. All right. From coming back to the dawn of time. Networking is relatively new. So when I say relatively new, basically tying into the adoption of the internet, at the end of the 80s and into the 90s. All right. So that was really where networking came into place. All right. So scalability. So scalability, what we mean is scalability is basically how do you add capacity? Because if you look at, we talked to say generation one, generation two of the web, we saw, how do you scale up applications to, moving from 10,000 to 100,000 customers to 100,000 to a million, from a million to a billion. How do you scale up? And there's really the idea of how do you add resources and be able to support, you know, all that number of connections. And there's really two ways to do it. One is what we call scale up, which you would get a bigger box, or you just scale out where you add more boxes. You just add more computers, add more compute systems into the mix. So those are the two ways you can increase your IT capacity. So cloud computing. So cloud computing is really a convergence of virtualization plus the internet. All right. So cloud computing really kind of came into the first commercial one was put out by Amazon in 2007, called Amazon Web Services. It is right now the largest, probably the largest infrastructure as a service uh, cloud implementation that's out there. What Amazon Web Services do is they have a large data center with large computers, and they enable virtualization. So what they'll do is they'll leverage virtualization. So they'll carve up these, these big server environments as a shared uh, uh, compute pool, storage pool, which then can be accessed by customers across the internet. So from a customer's perspective, what they see is they see a computer. They see a computer, that they can access on the internet, which is actually running inside of Amazon. So Amazon's the big one. You know, Azure, which is made by Microsoft, is the other big one. So those are the two, and primarily that was a lot of this stuff is what we said infrastructure as a service. So IaaS, infrastructure as a service, is that delivery of basically you're accessing compute infrastructure resources across the internet as a service. Software as a service is kind of taking that and going up another level. Software as a service, or they call SaaS, is the entire application. So it's not just the infrastructure. In these cases, you don't even see the infrastructure. All you see is the application. You get to the application across the internet. All right. So if you think about how, I think the examples around this, the best one would probably be Salesforce.com. All right, which is a CRM application, which the idea is that you don't have to worry about the hardware, you don't have to worry about the network, you don't have to worry about setting it all up or upgrading it. You basically connect in across the internet. Right? And then platform as a service kind of sits in between those two. Right? PaaS, as they call it, is infrastructure as a service, combined with specific application like development resources or database services together, which enable you to build things on these cloud platforms. So an example would be Amazon has a number of different kinds of databases you can use, inside their cloud. So the idea would be is, okay, you come in, you set up X number of systems, you write a whole bunch of applications using Amazon's tools. You're using a platform as a service. A lot of you see both Amazon and Microsoft, basically they offer, you know, these tools and support on these tools for free, because in a lot of cases, once somebody gets onto these systems and the applications are based on this, they're locked down to that platform. Right? So there's three different types of implementations of this stuff. Right? The way it's actually deployed, something we call public cloud. So public cloud is really what we talked about. That's Amazon and AWS. Public cloud is publicly accessible cloud. A private cloud is basically taking the same kind of cloud technology, but running it behind your own firewall, inside your own organization, not accessible by anybody else. It's kind of like virtualization. So there's a lot of overlap between private cloud and virtualization, but there's things like there's a dynamic aspect to clouds. Like, for example, you can add resources and get rid of resources dynamically. I can add 5,000 servers to my network, in like 15 minutes. I can get rid of them just as fast. All right, so that's the dynamic nature between that and virtualization. And hybrid cloud is really just combining a public cloud and a private cloud. different generations of the web. Web 1.0, which is really started in 91, 92, very simple, basically content focused web pages. And then kind of fairly rapidly evolved into what we call Web 2.0, which is really interactive web. So the idea of a Web 2.0, Amazon is a great example of Web 2.0. Google is an example of Web 2.0. All right, more and more sophisticated, interactions. A lot of stuff that, obviously the core functionality of the client server model is there, but there's a lot of stuff around presentation, being able to do all sorts of stuff, both at the, in the browser and at the web server level, be able to access databases and all sorts of stuff. That was all part and parcel of Web 2.0. Right. Web 3.0 is really the kind of what the next generation is. Hard to say what the line between Web 2.0 and Web 3.0 is. There's a lot of different terminology, a lot of different views of it. Think of it as, kind of blending artificial intelligence and newer technologies into the web. In addition, we also see things like the Internet of Things coming into play. So being able to support different, not just simply browsers or not just simply computers, but other types of communication. It can be leveraging the web. That's going to be what 3.0 is. And it's going to be larger. So the size, the other thing, the characteristics is the size. So, this was about a million. This is about a billion. This is about 2 billion users on it. Effectiveness and efficiency. All right. There's a, if you kind of look at this and say effectiveness is a measurement of what was the result that was achieved. And efficiency was how, basically what was done to achieve that result. So you can have an effective result, so it works, but not efficient. It could take you 3 weeks to do it. All right, that's kind of an extreme example. And conversely, you can have something that is efficient, that, okay, I can do it in 3 steps, but every 5th item is wrong. So that would be efficient, but not effective. All right, so that's really the example of and really what you strive for is a combination of both effectiveness and efficiency, balancing those two. We talked about the 3 different types of MIS systems: transaction processing systems, decision support systems, executive information systems. Transaction processing systems are basically is what drives ERP and CRM and SCM. It's driven around, built around execution of business processes through to one step at a time, one transaction at a time. Decision support systems, there's that the next level up of around from a business intelligence type of area where you're taking large amounts of data that are actually generated by the transaction processing system and analyzing it and using it to help support decision making. Because the idea is, okay, that's where your semi-structured decision making gets done. And executive information systems, which we had talked about, the idea of an EIS system, providing a representation, visualization of, KPIs, CSFs around the organization, giving kind of a snapshot or dashboard of what's happening in an organization as it's occurring. Internet of Things, basically taking, right now the internet was pretty much came up with, was the idea of a computer and a browser running a computer, talking to a web server, across the internet. And we kind of expanded that up as we went into smartphones and mobile, as we've expanded that domain out. Internet of Things is taking that to another level where we're actually going to be adding more anything that has a potential compute capability, so like appliances and automobiles and things like that. So we were talking about another wave of technology and types of systems that will be accessible and usable across the internet, or will be connected to the internet. All right, so the implications really it'd be interesting, because the one issue that has happened quite a bit is that the security associated with it is probably not is what it needs to be. So the idea of companies are putting things internet as a Internet of Things, creating kind of an Internet of Things. The question is whether we're ready for it yet, and what would you need to do in order to have security and the types of things you would need to manage it yet. So we shall see. Workflow is really the end-to-end process. Basically how an organization does achieves or does a particular set of tasks. You know, so there's like basically tasks, and then there's decisions that get done within that task. Okay, the internet components. So we've got very simple. So you've got the web server, which is basically a server running software that enables it to talk on the internet. That's a web server. HTML stands for Hypertext Markup Language. That's actually the language of the internet. That's the format, the structure, the protocol of messages that get passed from a browser to a server and returned. All right, so that's the content. So and it's just text content. You can actually look at an HTML message and see what it looks like, or see what the message is. So it's basically just text. Um, and then once it goes back to the browser will take it, interpret what the screen does, and kind of will transform the commands into kind of a display on the screen. That's what a browser does. That's HTML. HTTP, Hypertext Transport Protocol, is basically the communication protocol that is used. It passes over the internet. This is the pipeline, or the means by which a message is carried from a browser to a web server and back. URL, Universal Resource Locator, is this thing up here, top of your screen. HTTPS colon slash slash plus. It's a request. Basically, it combines the address and the what you want to get. So obviously there's Google Plus. This will be routed and interpreted on the web server, to execute what you want to do. The web server can understand what this request means, right, and then return it. All right. So the actual internet itself, I think is interesting. You see www.amazon.com, www.nytimes.com. The internet doesn't know any of that stuff. If you were to go on the internet and just put that in, you'd have no idea. The internet is actually everything on the internet has an address, but it has to be a unique address, and it has to be made up of four sets of numbers. So it's a number. So the actual address of everything on the internet is a 4-octet number. Okay, business continuity planning and disaster recovery. Business continuity planning is a business function. If you're a business, basically part of what the business continuity planning is, okay, what are the most important things we need to do in case of if we have a disruption to service? What do we want to do? What's the sequence we want to bring it up in? All right, what gets done first? What gets done second? What gets done third? What are all the tasks we have to do? So this is a business plan. Right? It needs to be done by business people. Has technical content in it, but it also refers to the disaster recovery plan. So the disaster recovery plan is the more technical side of the BCP. All right, so that's actually more around, okay, we need 10 servers, and we need this type of network connection, and we need this, and this, and that. All right. The BCP is kind of the business plan, created, signed off by the business, around this is what we're going to do. All right. Different IT roles, a couple of these roles: CIO, Chief Information Officer, top person in the IT organization. Not necessarily the top technology guy. All right. CIO is actually a business person. He's actually somebody who has to be able to liaison both on the technology side and on the business side, and understand how business requirements are translated into technology, and how technology can be used to enhance business. All right. An infrastructure manager, basically the person who's responsible for all of the plumbing, so the hardware, the software, networking, all of the infrastructure, all the stuff that makes up the infrastructure that is supporting the organization. Enterprise architect is a role that is really involved with kind of taking, also, kind of synthesizing the business side of things, the business architecture. How do we run things? What are the business processes? Aligning it with the different types of applications, and then the technical infrastructure, combining all of that together. So the idea of being able to deal with stuff at a detail level, understanding kind of what all the component parts of the detail level are, and then also being able to move it up and understand it at a higher level of how the whole thing comes together. ERP, enterprise resource planning, is a function. Basically, ERP is the amalgamation of all of the different business processes that are executed by an organization. It's manifested in software as an ERP system. All right, but putting it all together is the enterprise resource planning. If you look at the term enterprise, covering the scope of the entire organization. Resources is everything you're working with, and then planning is obviously planning them. All right. And then Porter's generic theory of competition, how it could be used to shape an organization strategy. If you recall, Porter's strategy, Porter, he basically said there's two things you compete on. First thing you compete on, you compete on price. You come with the lowest price or cost. You will succeed. Obviously, ideally, what you want to do is you want to make sure your cost is not your your costs do not exceed your selling price, because it becomes a very short organization if you do that. But you compete on that term. And then the other thing he said is, if other than that, it would be this idea of focusing, identifying something, some asset, or maybe combination of assets that collectively give you an advantage, and allows you to compete against other organizations. It could be location, could be you know relationships with suppliers, relationships with customers. It could be what how you run any number of things. But it's those two. It's those two items: costs, focus on costs, or focus on um, a specialization, a focus, this particular focus. Those are the two. Those are the two elements that Porter says at the core is basically how organizations will compete in a marketplace. And that is, I think, everything we will need to cover for exam one. Thank you.